everyone. I hope you enjoyed your spring break and everybody is nice and safe and healthy. Today, we're going to continue with hypothesis testing. And it's good because if you got 8.1 to 8.3, then you should get 8.4 really easily. So we're going to do a Z test for a proportion, and it's rejection regions and p-value methods. Since we already went through that with the first three sections, we already know how to do both methods. So we're doing a Z test for a proportion. Just like confidence intervals, we always use the Z for a proportion. It says how many hypothesis or many hypothesis testing situations involve proportions, which are percentages of the population. To use rejection regions, we state the hypotheses and label the claim like always. We'll be using P in our hypothesis instead of mu because we're testing a proportion. So when we test proportions, we use P and not mu. So you have to remember that. We find the critical values and sketch the sampling distribution with the rejection regions. Remember the critical values, we find it with the inverse norm, and I'll write that down. So we always find the critical values with the inverse norm. And then step 3, we compute the test value. We use the formula for Z, which is the test value or the test statistic. The P hat is the sample proportion, just like before. In this formula, the P is the population proportion. And then the Q is 1 minus P. And then again, the step 4, like always, we make a decision to reject, fail to reject the null hypothesis, and we summarize the results. So remember, going back to reject the null hypothesis, if you reject the null hypothesis, your test statistic is in the shaded region or test value, whatever you want to call it. So if the test statistic is in the shaded region, we reject the null hypothesis. And then if the test statistic is not in the shaded region, we do not reject the null hypothesis. Remember, we're always talking about rejecting or not rejecting the null hypothesis. And then the summarizing our results is one of those 4 statements that are in your table. And you guys are kind of lucky. It stinks to have to be going through this all remotely and not being able to ask questions in person. But for your tests and quizzes, you're able to use that table in front of you. You don't have to memorize it like in years past. So we're going to use the traditional method, which is also called rejection regions. You should get used to both of the terms. Because you might have to take another statistics class if you didn't sign up for this for RCBC credit, or you might have to take a Stat 2 class or something, and you're going to have to know either rejection regions or traditional method. So we go through just like before. We state our hypothesis, our hypotheses, our null, and our alternative. Remember, it could be H sub 1 or H sub A. But because we deal with a proportion, there's a probability in this one. We're going to be dealing with P. We don't write mu. Make sure you do not write mu. So an educator estimates that the dropout rate for seniors at a high school in Ohio is 15%. So that's my 0.15. So that's my P, which I know then my Q is 0.85 because it's 1 minus that P. Last year, 38 seniors from a random sample of 200 Ohio seniors withdrew. So X is 38 and N is 200. Remember, N is always the bigger number. At alpha is equal to 0.05, is there enough evidence to reject the educator's claim? So there's nothing about a less than or greater than, so I have to put a not equal to. Because this is talking about rejecting a claim, then our null hypothesis has to be the claim. And also it says in here that an educator estimates that the dropout rate for seniors is this. So that's telling me that my null hypothesis is my claim. So that's my first part. Now I have to find or sketch my sampling distribution and find my rejection regions. So it's a 2-tail test and alpha is 0.05. So that means in each of these tails, it's 0.025. So we're going to have 2 Z's. So remember to find this Z, it's equal to the inverse norm, is 0.025. And remember, this is called the critical value. So the inverse norm of 0.025, this is going to be negative 1.96. So we know my two critical values are negative 1.96 and 1.96. Now we use our formula to find our test statistic. The formula, just like for confidence intervals, is just a little messy to use. So it's P, which is P hat, which we are not given. So P hat is X over N, which is 0.19. So Z is P hat, which is 0.19, minus P, which is 0.15, divided by the square root of P, which is 0.15, times Q, which is 0.85, over N, which is 200. It's up to you how you want to type this into your calculator. I usually type in the top, and then I would do 0.15 times 0.85, press enter, divided by 200, press enter, and take the square root of that number, press enter, and then divide them. And no matter what you get 1.58 approximately. And if you round differently when you're doing your calculations, you might get a slightly different answer, but it's not going to make a huge difference. So 1.58 falls in the non-rejection regions. Since it's in the non-rejection regions, then we do not reject the null hypothesis. And again, if it's in the non-rejection regions, we do not reject the null hypothesis. We're always talking about the null hypothesis. So then there is not enough evidence to reject the claim. And just to point out a couple of things, again, since there's non-rejection, didn't go on the highlighter, non-rejection, we do not reject and there's not enough evidence. And then because the null hypothesis is a claim and the problem talks about rejecting, we write reject in our sentence. So it's really, really similar to what we did before, except the formula to find this Z right here. That's the only difference from what we're doing. And writing P instead of mu. So next one, again, set it up. I see a percent here. So as soon as I see a percent, I know I'm going to have to use P. Because we all know that the confusing part is when we put it all together. Each section is easy on its own, but when we put it together, it could be confusing. So an attorney claims that less than 25% of all lawyers. So this is probably going to be my claim because it says it. So P is equal to 0.25, which I know right away that Q is 0.75. A sample of 200 lawyers, it just happens to be the same N as the last problem. And X is 39. At alpha is equal to 0.05, is there enough evidence to support the attorney's claim? So this problem says support. That means that the alternate hypothesis is the claim because support is always talking about the alternate hypothesis. So we sketch our sampling distribution. Alpha is 0.05 and it's a left tail test. So my Z is equal to the inverse norm of 0.05, which is negative 1.64. We use the negative because it's a left tail test. If it was a right tail test, I would use the positive 1.64. Then again, I need to find my Z. So I'm going to use my formula. So Z is equal to P hat, which again, we didn't find. We weren't given. Sometimes we are given it though. It's 0.39. Oops, not 0.39. Sorry. 0.195. So P hat is 0.195. So it's P hat minus P, which is 0.25, divided by the square root of P, which is 0.25, times Q, which is 0.75, divided by N, which is 200. So we wind up getting negative 1.796. So when we graph that, we know that our test statistic is in the rejection regions. So we reject the null hypothesis. Because we reject the null hypothesis, there is enough evidence to support the claim. And again, we can always go back to this sentence. It says support, so we need to have the word support in it. This does not have the word not in it, so this does not have the word not in it. Unlike the one before, where this has the word non-rejection, do not reject, not enough evidence. Rejection region, reject the null hypothesis, and then there's no not. So that's how to do hypothesis testing with rejection regions or the traditional method, whichever way you want to describe it.